Let's talk about this one. Resonance structure of this one. You see there's an oxygen being negatively charged. Okay? So one thing you can do, this comes in and there's electron pairs go to oxygens. This is a nitro group, by the way. That's one of the resonance structures. But another one can be drawn by this double bond. If a double bond comes in between these two, then this electron pairs goes out. It makes a very, very minor contributors. I don't like to see that one, but if you really want to draw it, you can draw a minor contributors. Doesn't really matter whether you draw this one or not. One thing that is these two exist. These two are the major contributors. But you don't do the other way. Oxygen going this way, carbon comes out. If you make the carbon negatively charged, oxygen positively charged, that's bad. That is one thing I was talking about. You drop the ball in the air, you expect it to go to the sky. Maybe some other word, not this word. Okay. Not that yet. All right. So those are the main, and these are something that is extra just point out there. Sometimes you can probably draw the minor contributors, but that's really doesn't count that much. I mean, it still can draw. But what about this one? That's a completely neutral molecule. As I said, sometimes when you see the molecule positively charged, negatively charged, you see that you kind of felt that maybe resonance structure possible. But this was a completely neutral molecule. So you thought that there's no resonance structure possible because there's a double bond, but there's nothing else to move around. One thing that you gotta remember that nitrogen is a lone pair. Sometimes we don't draw that. But it is there. So this lone pair nitrogen, see the double bond line next to it. So we can do, it comes in, make a carbon nitrogen bonds, make this little pair to go with oxygen. That makes nitrogen positively charged, oxygen negatively charged. Still, octets are met for all of that. So it's not the octet reason. It's all because of the charge separation. That becomes a minor contributor to this one. Resonance structure is still possible. If it's a minor contributor, why do we have to draw this one? You made them that way. So one of the things that this is something that we're not going to discuss too much, but I'm pretty sure you're going to take a biochemistry next year. This is going to be some major concept biochemistry, even though this carbon nitrogen bond, then look single bond, it actually carries partial double bond characteristics. There is a amide bond that makes a protein, while the proteins are shaped a certain way. That partial double bond characteristic between the carbon and nitrogen can be explained by the minor contributors, like a double bond there. So sometimes the minor contributors, even if it's minor, it explains why it shows certain characteristics. So that's why we sometimes count the minor contributors carefully.